So we're just going live here. We never really know when YouTube is going to take our stream. And so instead of me just standing here looking like a silly bugger, I'm going to just talk for a little bit. We've got a really great live stream planned for you guys today. And we're going to get going here in just a couple seconds. You've got your standard video game advertisement there starting right in front of you, and looks like we are live. Okay, folks, Rob Avis here with Verge Permaculture, and today I'm with Sarah Reeves and Tim Krahn, and I hope that I'm saying your name correctly there, Tim. And yeah, so we've been on hiatus for a little while, and actually I forgot to mention, if either of you guys are on the YouTube side, make sure that you're muted, just so that we don't end up having the reverb going on the back there. So we've been a bit on hiatus, guys. I've been sailing in the Baja, and actually we ended up seeing some really great stuff while we were down there. We produced a bunch of videos on our YouTube channel. I also got to interview Brad Lancaster, so that's coming up soon on the channel. There's gonna be some really great content from that trip. So we weren't just drinking Coronas on a sailboat. We actually were doing a bit of work down there. I'm really excited to be kicking off the Ideas on the Verge again, now that we're back from that long trip. And we've got a really great roster of authors to talk to, and for you guys to co-interview with me as we open it up for questions at the end of this session. And today, I've got Tim Krahn, who's a PEng, and he's going to be talking about rammed earth construction. But before we get into that content, I'm just going to give you guys a little preamble. If this is the first time that you've come to Ideas on the Verge, we created this program as a result of working with New Society publishers, writing our rainwater harvesting book, and decided that we wanted to find a way to collaborate with New Society because they have so many incredible authors with so much incredible knowledge that can be shared throughout the YouTube verse, I guess. And give opportunities for the people on our channel to ask questions of these incredible thought leaders. And so we're kind of in a bit of an interview phase right now where we're going through the Essential Sustainable Building series, which is an incredible series that New Society has aggregated and brought all these great minds together to build books that are absolutely densely packed with the most important things on that particular subject. And so today is rammed earth construction. We've talked about light clay straw. We've talked about rainwater harvesting. We've talked about sustainable home design. And there's literally a whole series. And I'm really seeing the opportunity to have a box set here, which I think is going to be available at some point soon. So before I bring Tim on, I'm just going to get Sarah to talk a little bit about New Society publishers, and then we're going to get straight into the interview. Keep in mind that at the end of the interview, we open it up for questions, and would love for you guys to start thinking about questions about rammed earth construction, if you've got any. It's going to be a really interesting interview, especially talking about this subject in a climate like Canada. Sarah.
Great. Thanks very much, Rob. And hello to Tim. I'm really excited to be here as usual. So for those of you who don't know, New Society is an activist solutions-oriented publisher. We pride ourselves on walking our talk and having the highest environmental and social standards of any publisher in North America. So this includes printing on 100% post-consumer recycled paper, printing in North America and never overseas. We've been a carbon neutral company since 2006. Our employees are shareholders in the company, and we're also a certified B Corporation. So we often say that our books are so green you could eat them, but you probably shouldn't do that. If you want to find more out about us, check us out on our website, newsociety.com, or any of your favorite social media sites. We're thrilled to be able to collaborate with Verge Permaculture on this project. I think that the sharing of ideas and information on as many platforms as possible is key to creating community and real change in the world. So I want to give a shout out to all of our authors for their willingness to share their often hard-won knowledge and expertise with our readers. It can really be comforting when you're embarking on a new project or contemplating new and challenging ideas to know that someone's been through it before you and can walk you through it, helping you to miss the many potholes that reveal themselves along the way. So thanks everybody for joining us, and I'm really excited about today's conversation.
Awesome. Well, thanks for joining us, Tim. To get us started, why don't you tell us a little bit about what you do, who you are, and what got you interested in rammed earth construction?
Okay, thanks, Rob. Yeah, I'm sorry. I'm a professional engineer, licensed in Ontario, BC, Manitoba, and Northwest Territories and Nunavut. And I'm a partner in Building Alternatives. And together with my partner, Chris Dick, he's recently retired prof from the University of Manitoba. He's licensed in Saskatchewan and Alberta. So we've kind of got the western, central, north, mostly part of Canada covered. I'm a recovering Mennonite. Say that with my tongue firmly in my cheek, but a lot of that heritage, in terms of being involved in relief work, has stuck with me, and that's one of the reasons I became involved in sustainable building. My master's degree is in geotechnical engineering, so I did a lot of work. My master's was on flood control. And that taught me a lot about how we can use available materials to build walls. And in that case, it was sandbag dikes. But a lot of the knowledge really transfers quite well to rammed earth, depending on how you look at mechanical stabilization and cement stabilization and all those things. We don't need to bore people too much, unless you really want to be bored. You can ask questions that get into that the weeds later on. When Chris started Building Alternatives, he was really getting into things like straw bale construction. We still do a lot of that. We also do timber engineering, so building with wood, building with cellulose of all types. And I guess since I joined him in 2003, we've really been able to bring in the whole soil aspect as well. So we look at fibers, we look at granular materials, we look at combinations of the two, and we try to facilitate healthy, sustainable building everywhere in Canada.
It's pretty cool to, I was just on your website before we hopped onto the call this evening, and to go to your contact page and basically say, thanks for getting in touch, but we've taken our form down because we're just too busy. And for somebody to be in an alternative building, industry like you are, taking on all of these, we'll call them strange, even though I think they're the way that we should be building, methodologies, to be basically saying that we can't take on any more work because we're so unique within our space, I think is a pretty incredible testament to the fact that you guys are doing something right and that it's resonating with people. Yeah,
there's also some personal survival sustainability in there too. I've seen a good number of of colleagues, both in more alternative and in conventional engineering, burn through several marriages and their health, because if you're competent, you're busy. It really is that way. And I decided that I like being married. I like being married to Delilah, and I'm trying to be healthy. So that's part of the whole backing away. I don't want to build a business. I don't want to, but that there is an opportunity here and I do hope to be able to pass along to young engineers or just curious engineers, architects, designers, how to analyze and how to design from a rational point of view, a defensible point of view with these materials. And really that for me was a big goal for writing the book, was to learn what it takes to write a book. And this book is geared towards DIYers and experienced builders, but I hope in the future to write books that are geared towards engineers. But not there yet. First we have to get our feet wet with this stuff.
Yeah, totally. So you kind of mentioned that you got a background in soils. Did you always know you wanted to build with this type of building system?
Well, when I was doing my my master's, I'd already spent some time, curiously enough, in the Baja, was working through an orphanage down there, and that particular area is a strong masonry culture. I mean, they're hard pressed to grow a tree there, so they tend to build with masonry, and I saw the potential to work with things like sandbags or earth bags, and then through my master's, I was able really hone some of that from an engineering perspective, and to come away thinking, well, we can do these things to prevent water flowing on one side to go to the other, or to slow it down. But if we control this whole structure and we don't put water on one side, can we make a wall out of this? And then I was introduced to Mira Krahenhoff, and I saw what he was doing with stabilized insulated rammed earth in Canada. And I just fell in love with the aesthetic, which as an engineer, I'm maybe not supposed to be qualified to say anything about, but I just think it's stunning. And I learned that we've actually been building with it as humans. We've been building with it for thousands and thousands of years. The addition of stabilizers, relatively recent, but not that recent. The Parthenon, the dome of the Parthenon, is essentially a rammed earth structure, from the stabilized rammed earth structure. That's Roman cement, a pozzolan mixed with a granular mix, and then tamped in forms, dry pack, tamped in forms removed, and it's been there for a long, long time. I haven't met any builders who are excited about doing a dome out of rammed earth yet. So we mostly stick with straight walls, but curves are possible. Yeah, and I think, sorry, go ahead.
Yeah, no, I was going to ask, I mean, for folks that are just kind of new to this concept, can you talk a little bit about what rammed earth construction actually is?
Okay, so if you're familiar with cob, cob is kind of fiber reinforced rammed earth without forms. So cob, you're taking a mix that's really sticky, pretty dense, got a lot of straw in it, and you're putting it into lifts. You're using your cobber's thumb, and you're building up a wall, or you're surrounding a masonry hearth. Well, let's make that mix just a little bit drier. Let's take out pretty much all of the straw, although you can do fiber reinforced, but it tends to show, so people want to show off their rammed earth. So, and we build a very stiff formwork, and we deliver our damp mix in 6 to 8 inch deep lifts, and then we pneumatically, well, in Canada, we pneumatically tamp it, so we're using compressed air tampers. You can do it manually. There's no, it's really just it's a matter of increased densification and potentially labor savings if you bring in machines like that. I have some colleagues in India who swear that you're going to ruin your shoulders if you're holding those tampers, and they advocate for just manual tampers, just the same kind of tampers that you can buy at a hardware store for tamping down sod, or a common landscape tool. And then we take our formwork away, and our wall is revealed. And often people are putting in dyes or embedding other materials. There's some, Clifton Schooley does some amazing stuff out in BC, where he uses relief, both relief into and out of the form. So and you can create amazing shadow lines with that. I strongly recommend looking at his stuff for that.
So when you're building it in these lifts, do you have to build an entire wall system within a certain amount of time before everything sets, or do you have some time flexibility?
Quite a bit of time flexibility. We would have a differentiation between a lift line and a cold joint. So on a given day, say you're building an 8-foot wall, on a given day, maybe you can do 2.5 feet with the lifts at about 4 to 6 inches once they're compacted down. And so you work through the morning, and then there'll be a little bit of a cold joint. If you break, you work through the afternoon, and then overnight there'll be another cold joint. But they're just expressed as a more definite lift line. But yeah, there's no, except for aesthetic, there's no limitation there. The oldest rammed earth was done with slip forms, and they just worked their way up. And again, cold joints were just a matter of the next day.
So then in terms of connecting multiple wall systems together, because you guys are lifting one wall and then connecting another wall into it, how are you guys creating those connections?
Yeah, the formwork is the trick. if you're going to reuse your formwork, if you're going to set yourself up, and this is very common for DIYers, they get themselves a set of formwork that will make X distance of wall, and
Right.
their whole house is 5X. So then they're going to have to build this in sections. Generally, we would use dowels to connect across.
Like wooden dowels.
Wooden or reinforcing steel or fiberglass. It depends on the structure, application, and the thermal issue. But probably most common for ease and cost is just rebar.
Right.
Steel rebar.
Okay. And do you have to create any kind of mastic in between the two walls, or is it as the materials coming together, there's enough of a key to connect the two wall systems together from an air infiltration perspective?
Generally, we have enough because our minimum wide thickness, if you will, is about 6 inches.
Okay.
Really difficult to tamp less than that. So you're putting like material to like material, and 6 inches is enough. You can key, and most of our stuff incorporates an internal insulation layer, and so that often ends up being the sort of the belt to the suspenders on the air barrier system.
So if you were to key it, I mean, theoretically, it's more work than it's worth, but you could put a positive or negative relief, I guess, so that your formwork would essentially lock in. Is that right?
Yep, absolutely. And it's not that much work to put a strip along an edge. I've got an example a little later to show how to get relief at the base of a wall with a pretty similar idea. Just making a positive indent on the formwork side, which creates the negative indent on the rammed earth.
So for Canada, do we all pretty much does our climate require us to have a two-wall system right through the country, or are there any places like on the West Coast where you can get away with just one wall without any insulation?
Would have to be a pretty thick wall.
Yeah.
But having said that, I think you could probably, push like a 16-inch wall. The thing is that, like I made the comparison earlier with cob, we're quite a bit denser, and we don't have this cellulose component. So the insulation value is really pretty poor. That having said that, the thermal mass is quite high, and one of the key differentiating factors between rammed earth and stabilized rammed earth, so cement stabilized or lime stabilized rammed earth, and concrete is that we allow the presence of clays, of very fine particles. So rammed earth, even stabilized rammed earth, will perform quite well in terms of humidity or hygrant capacity, absorbing and giving off humidity to a space. So that's a huge benefit, but it's only really realized if there is an insulation layer between that wall and the outside, whether it's hot or cold on the other side of that wall.
So does the wall end up being vapor open, meaning it has a perm rating that's going to allow vapor transmission?
No, we have with stabilized rammed earth, we would have vapor permeability in perhaps the first inch to inch and a half of the wall, and then there's just too much there. On in unstabilized or raw rammed earth, so there's no cement in that mix, you get maybe 2.25 inches into the wall that's hygrically active, where vapor is being exchanged. But again, once you get past that, the material just becomes too dense, too thick. The pathways aren't open anymore.
Right. And so I guess when you're doing a double wall, you guys typically will put some insulation in between those two walls. What type of, would you use like a Roxol or a perlite or something like that?
The example I want to show later is one with Roxol. I'm trying to find a builder who's keen to put a straw bale inside a wall, but that'll be a thick wall. So we'll see about that. Although you can retie. So that's another thing. I've met, there's a number of farmers here in Ontario who have given up on baling small bales. They bale huge bales, but then they have a machine that strips these things down and bales them in very small, whatever custom size. They can make just about any size of bale and just about any density. So that I'm kind of keen to find the right situation where we could create a custom straw bale that would fit in the wall and not end up with a 36-inch total wall or something like that.
Right. So you and I were talking a little bit about various exterior finishes, and it got me thinking that one of your walls internally for load bearing would mate really nicely with an EFIS system on the outside. And then you were talking about a rain screen, which is kind of going through my head yesterday as well. And so you get the benefit of thermal mass on the inside. It sounds like you end up with a vapor barrier as well. And then you could build out whatever R value you wanted on the outside of the wall, as long as you've got it properly protected from rain.
Yeah, exactly.
Like that.
Well, we've done here in Ontario, we've done one where we did a straw bale, a plastered straw bale wall on the exterior, and then a compressed earth block wall on the interior, which is essentially that build up, but it was the discrete block masonry rather than the rammed earth wall. But that building is performing very, very well. He's got it was designed with a proper overhang, continuous overhang at 8.5 feet. So he does have an exterior plastered wall. I mean, in my belt and suspenders world, I would want that rain screen. They don't have it there, but they've got a low enough, wide enough eave that they're doing well. They've also built up with a stone masonry veneer on the outside of the bottom to protect from backsplash. So that's a pretty good system right there.
So it sounds like you guys have done stabilized compressed earth bricks then as well.
Yep.
And so do you have a Vermeer unit then, or what do you guys use to build those?
I can't remember the name of. It's Henry Wiersma at Fifth Wind. He's near Cold Springs. He bought a big unit from Texas. He can make a lot of blocks in a day. He's having more issues right now setting up his shop and running his getting labor to make the blocks. He's got more theoretical capacity than real capacity at this point. But I have seen the Vermeer units. I've also seen Cinveram. There's a version that my colleagues in Bangalore at the Indian Institute of Science build and sell. Those ones are manual. Then you're not using hydraulics or a diesel generator or anything. You're just using physical, a long moment arm really. But you get lower capacity. You get lower strength because they don't incorporate a vibration step. Then
lower strength than a monolithic wall.
Yeah, definitely lower strength than a monolithic wall, but also so the compressed earth block machines that are motorized,
right,
they riff on what we've learned from making concrete, like hollow concrete blocks, and that is to incorporate a vibration into the step just before compression, and you really can double your compressive strength by rearranging those particles just before you press down. It's very impressive.
So speaking about bricks and walls and assuming that they're similar, how sensitive is the system to the type of soil that you have? Like when you get a project, do you have to have a really detailed analysis of the soil structure before you can design the wall system?
The short answer is yes. The more complicated answer is to say, well, are we going to build a raw rammed earth or are we going to build stabilized?
Right.
So if we're going to just build this interior wall and we want to really minimize the carbon footprint of our wall, then our only binder is going to be clay and the state of the wall in terms of matrix suction from the geotech point of view. And then you really need to dial in your mix.
Right.
But it's doable. It's been done for hundreds and thousands of years. So it's doable, but it's work. You're going to have to go through a number of iterations. You can incorporate site clays if you have the right kind of clays. And my book has a whole section on testing. You can figure out whether you've got an issue with shrinkage. That's really the biggest thing with clays if you get into the Montmorillonite type of clays, like I'm from Manitoba originally, and Red River gumbo is not appropriate. Stuff will shrink and swell over 300% from bone dry to fully saturated.
Right.
You don't want that in your wall. It'll just tear your wall apart. But there's kaolinites that are, so if you know somebody in your neighborhood who uses their clay off of a riverbank or something and makes pottery, that will actually hold water, like not raku or something, the chances are very good you can use that clay. You can also buy, American Clay is selling clays that would be very appropriate. If you know someone who has a pottery store nearby, you could get clays. So then if we're going to do the stabilize, we're going to have cement stabilize, we're going to put some lime in there, we're going to do something like that. That's a much more forgiving mix.
Right.
But there's no free lunch. You want the easy mix, it's going to cost you an embodied carbon.
Right. But realistically, we were talking about this yesterday. We're talking a pretty small amount of the mix is actually cement. Like if you were to compare it to a concrete wall.
Oh yeah. Yeah. We're 25 to 30% of that. So they are 3 to 4 times the amount of cement in their mix. So we do end up with it's definitely better insulating than concrete, but most people don't even entertain the idea of using concrete as an insulator. So,
Totally.
Yeah.
Cool. So why don't we bring up some of your photos so folks can see a little bit about what you're talking about here. That always helps to visualize all of this stuff. If you want to share your screen and just take us on a bit of a photo tour.
Sure. So what I wanted to, can you see that?
Not yet.
Oh, I have to finish that, follow through, and hit the share button.
There you go.
All right. So what I wanted to emphasize was form work, and we can go through some photos a little later of what the finished wall looks like. But you're creating, when you put up formwork, you are creating the negative shape, the volume that you're going to put the wall into, and it's going to be forever. So it's really worth doing it right. This is an example from Abbey Gardens near Halliburton, and so this is can you see, does my cursor show up there?
It sure is. Yeah.
Yeah. Okay. Great. So this is an aluminum system, alumiform, and these are all pretty much the same kind of eye sections. They got slots and stuff, and they fit together. And you can see that we've got one side of the form. This is form ply. One side is going up all the way. And the delivery side, we go up in stages. And in this case, we're using 4 foot. You could theoretically do 2 foot sections, but most of the builders here find that that's too onerous. They want to go up in 4 foot sections. Depending on where you are in the world, you may or may not be able to be inside an enclosed space like this. California, you definitely can't. So if you're looking at David Easton's work, for instance, they are forming both sides continuous and then delivering and tamping from the top with extended tamper ends. Here in Ontario and most of Canada, it's a 5 feet is the amount of is the height of a constrained space that you can put a worker into. So if we're at 4 feet here, we're okay. Does that make sense?
Yeah.
All right. So I wanted to show you the bottom of this form. So in this case, the builder has come up with their own little bracket to cantilever off of a footing. And we have this coil tie that's going through and holding that bottom together. And we are putting, when we run those tampers, we're putting a lot of pressure laterally on the forms. So right. Here's an example. This is coil rod and coil ties is essentially little pieces of spring welded together. And these give us quite a bit of flexibility in this system. I'm going to show you another system a little later that doesn't have these kind of ties. So now we're looking down into the formwork, and in this case, we have the mineral wool. It is Roxel, although I think they're now called Rock Wool. I don't know why they decided to rebrand, but they did. You can see that we've drilled and epoxied vertical rebar in, and you could cast your rebar into the footing directly, but generally speaking, for accuracy, we find that drilling and epoxying later or mechanical anchors is better. that may not work if you're in a high seismic zone and you need to actually bend those bars and engage more of your footing. But this is Ontario. This is that strip that I was talking about earlier, and it's just a strip of form ply ripped. I think it's about 3 inches long, and that's applied. This is the interior side of the form, and so that's gonna leave a little negative space. And then when they are putting their floor in, their finished floor height is going to be about 3/4 of an inch below the top of that. So they're creating a really nice shadow line at the bottom of that wall. Now we're going to work our way up a little bit, and you can see that we've got these spacers made so that we can hold the insulation where we want it in the wall section.
Right.
You can also see the coil rod and coil tie. So that coil rod, from a tension point of view, is continuous, but we embed this tie here, and when we're done, we can just pull that section of the coil rod out.
Mm-hmm.
And so this is the outside of the wall. So we are trying to minimize our thermal bridge. We don't have the steel going all the way through.
Right.
We do have a little hole that we're going to do something with later, but now we're working our way up. You can start to see progress.
So the rock wool, that must compress a little bit as you guys are tamping that, right?
Yep. No, we're definitely losing a bit of its insulative value as although I shouldn't say that if you're using the high end, the comfort board stuff that's already a 30 psi rated product, apparently, even though we are compressing it a bit, we don't lose any thermal, and that agrees with what I know from compressed cellulose. The point at which you would start to lose insulation value in a straw bale is in excess of 50 pounds per cubic foot, and most straw bales that you just get from a builder are between 5 and 10 pounds per cubic foot. And then, as a little side, you start to lose the bad aspects of creep behavior if you get above 20, 25 pounds per cubic foot. So that's another reason I want to use these special compressed bales, is be able to use the bales as structure. That's more engineering, blah, blah, blah.
That's cool.
So now you can see where we've got a little guard on the top of the insulation. We've got our spacers. So this is, the workers are going to walk on the insulation.
Wow. And
in this case, we were actually looking to thermally isolate one of the wives. So we've got high strength extruded polystyrene at the bottom of this wive. One of the other projects we went to that had a little bit more budget used a foam glass.
Right.
Corning's Corning poly, whatever it's called, Perinsol, that's what it is. Anyway, these guys didn't quite have that money, so they put some foam down there. And you can see us from the outside now, where this is an important note. You need to have strong backs, fairly tightly spaced to handle the outward pressures, but you also need enough width to deliver your material. So we got a bucket coming in here, and you can see here's a strong back at the edge, and then we have a pair of them that are too tight to get a bucket in, but on the other side of them is open again to be able to bring in a bucket and deliver material.
And so are you mixing that in a cement mixer or a ribbon mixer of sorts?
It is, in fact, a mortar mixer. So it's a horizontal axis paddle mixer.
Yeah.
The kind of corkscrew cement mixers do not work. The mix is too dry. They just get bunged up.
Right. So
I can show you some photos of that later. This is just a trick that I think is brilliant. This is just a piece of plastic J trim put on the top of the plywood, like along that, so you can see that white strip, so that you save that edge for to get a nice crisp line. So you can see that we're going to have these lines, and those lines will be expressed in the wall. So I'll show you another one a little later with that. So here's wish that was up. So here's a spot where attention to detail was not perfect. And that's the end of one of those coil ties.
Right.
And so when the forms were stripped and this was pulled out, it actually blew out. And that, you've got to be careful with that kind of thing. Here's one where it didn't blow out, but we had a stress concentration and we've got a crack.
Right.
And here's one where this lift.
Can you zoom in on that just a little bit?
Sure, I can.
Perfect.
This lift, the lift that they put the oxides into to dye black, is actually a little thin. And so when they put that on and started tamping, they actually caused spalling in the lift below, because this material the thinner lift didn't disperse the forces laterally as much as necessary. And so it actually damaged the lift below. So these are, I'm trying to show some, don't do this.
Right.
If you look around, you'll find all kinds of inspiring, beautiful photos and ideas, but this, I'm trying to maybe I don't know. I'm not trying to convince people not to do this, but I'd like to figure out, have them think about how to not do it.
Well, win, lose, or draw, right?
Yeah. Yeah. So here's a situation where we're looking at a different, this is a lower cost, sort of more DIY form system. Again, strongback, in this case, the strongbacks are just evenly spaced so that they can deliver into each of these units. The thing that I would like to point out in this is that the whalers aren't continuous across 3 strongbacks, and they really, really should be. So in this case, we've got a weak point here,
right?
Where when the plywood wants to flex outward, the whalers aren't continuous between at least these 2 strongbacks, and so it will flex, and we can have that. That's not ideal at all. And here's a wall where what I want to show is that at the beginning, when they were forming it, they were careful about matching up form ply. And then at some point in the wall, they were either trying to save money or something. And so we get joints that aren't in line, both horizontally and vertically. And that's forever. So that's, yeah. I mean, maybe when you look at this wall, you don't see those things. What you see are so this would be a cold joint, and then these are lift lines. So this
right.
is, if this was a day, we probably did these 3, and then that's lunch, and then those 3, and then that's the next morning.
Right.
That makes sense. So we have 2 lift lines, a semi-cold joint, 2 more lift lines, and a real cold joint. Anyway, so if you're seeing those lines, maybe you don't see the form ply lines. All depends on your sense of vision. I don't know.
Right.
But
interesting.
Thinking about it is what needs to happen. Here's a mix. This was a mix done totally with site material in Manitoba, and it looks pretty cool. But you can see that the lift lines here at the bottom are quite a bit closer together than here at the top.
Right.
And it may not be completely obvious, but this is a lot more like lap siding than it is like a vertical. Like here, we're pretty vertical, but then we start to slope in and then bulge out, and then slope in and bulge out. And what's happening is the formwork wasn't stiff enough, and it is starting to bulge, so that at every lift line, we're pressing out and we're getting this relief. And it's I don't think it's ugly, but yeah. So here's another view of the same wall. And the lessons here are things like quality control. So this was the morning when they had an experienced builder on site who was coordinating the volunteers, and then he had to go, and the volunteers were no longer being coordinated. And that's when the lifts start to get really, really thick. And we started to have problems with bulging. And in fact, the material, like this is somewhere in the neighborhood of a foot.
Can you just zoom in on that, Tim?
Yeah, sure. So this is somewhere in the neighborhood of a foot, this lift. And really the bottom of this lift was not getting the effective compactive effort that it needed. and the homeowners in this case had to do some repairs, which is not easy to do after the fact.
Right.
So coordination, being very careful, it's a good idea. Here's a shot where everything's great.
Can you just zoom in on that a bit?
Yeah, sure.
Great, thanks.
So everything was going well. You could see in this dyed layer, pretty clean transition. And this dyed layer, they just put too much water in.
Right.
And so that's actually sort of, that's what the form would have done, pulling away.
Right.
And then you can start, if you look closer, you can start seeing little streaks of orange because that oxide then was just all over the place. So yeah, drier is better, generally speaking.
Cool.
Yeah.
So do you have a picture of a finished? You've got some on your book here. Maybe if you stop sharing your screen and you can pull one up, but just to give people a sense of what these structures actually look like when they're done. Let's see if I get it in focus. Sure. I don't know if you've got any of these photos ready, but if you've ever been into a structure with round earth walls, they are absolutely stunning structures. And I highly encourage, even if you're not going to build one, to keep your eyes out for them. They are starting to show up quite a bit more as well. I've seen a few in the Okanagan at some of the wineries, I think, have them as featured walls in their wineries and stuff. Like maybe you guys did that work, I'm not sure, but
I've been involved in a few. So here's a finished house near Huntsville, and you scroll through and just see a bunch of these are photos by Emily Blackman. She's a very good photographer, and you can see they incorporating it into a finished house.
This looks horrible.
Yeah, I know. It's just, how could you live in a place like that? This, yeah.
Hey, I got a question for you. What about radon?
Yeah, no, there's a great question. And it's totally appropriate with this house in particular, because this mix is the parent material is granite. So this is up in the Muskokas, it's near Huntsville, and there are granites, schists, gneisses that contain radon. So you need to test, but it's not an expensive test, and you can get samples from a quarry and you can get the tests, the little test kits, just about any home building place. And
do you use those Air Things units?
I beg your pardon?
Are you familiar with Air Things?
Air Things.
The testers?
I'm not, but that doesn't mean they're not good.
Okay. Yeah, no, we for our clients, we've got these little pucks. They look like they have a whole bunch of different ones. And
okay,
while radon does have a half-life and you have to watch it for a while,
right,
they will start producing results after about 48 hours. And they tell you not to rely too heavily on those results. But the nice thing with those is that you get a little bit quicker response than having to wait the 3 months.
Right. Yeah. So I'd recommend doing something like that, and then choosing against that mix if you start getting positives, because you don't really want to incorporate something like that into your walls on something that is going to be forever.
Right.
So, here's some exterior shots of that, but man, it's Macaulay resin. She's got a beautiful pond outside her place.
So the insulation cavity then looks like it's about, is it 6 inches thick? Is that right?
It can be whatever you like, but at this point in energy codes in Canada, 6 inches of either a foam or a rock wool is going to give you enough to be code conforming. I'm going to stop sharing for a second. Is that all right? Unless we want to. Anyway. So yeah, I mean, we did another house not far from this one near Huntsville that's Passive House certified, and they've got 15 inches of rock wool in their wall. So it's really how wide do you want to make your forms? There is an element of increased need for stiffness as those forms get wider apart, but it's all doable. Yeah.
So, I mean, if you're just going for 6 inches, and let's say you're using rock salt, it's like 3.8 per inch, I think. So we'll call that, R24, but it's not really fair to call your wall an R24 wall, because
right.
You've got the thermal properties going on inside. I'm curious, so we can bring this into the question about R values and what the true R value is in your opinion. But what kind of air infiltration rate do you get on a well-built house built with these wall systems?
Very low. I think the lowest that I've been involved with was 0.37. But that's all about detailing around window and door openings and at the top of the wall. So you've got a virtually impenetrable wall, but if you don't do a good job of installing your doors and windows, you're still going to leak.
Right.
It's just going to be concentrated at the openings then, which, it can be, on the one hand, you can access those and you can put a new door in, perhaps, if something goes wrong. But on the other hand, you don't really want to have problems with your doors and windows if you can avoid it.
Right. So just for folks listening, the Passive House Standard tries to keep the air infiltration rate below 0.6 air changes per hour. And Tim just said that the lowest he'd seen was 0.3-ish. So that's pretty incredible. And air infiltration, as long as you've got good mechanical systems to keep your air quality high, air infiltration is always the lowest lying fruit. And so we always think about R value, but you can have a really high R value in the wall or in the windows and a poor air infiltration characteristic and end up kind of defeating the purpose. So that's really amazing and it makes sense. I mean, I guess it's pretty tough for air to move through those walls.
Right, exactly. But the whole thing works as a system. And so it's one thing if you've got a single story or a 2-story, you're going to have different pressures at the top of your wall, depending on the height of the wall, stack effect. It's really good to get into the building science thing. And you said you had an interview about building science earlier, and sustainable design. Was it more sustainable design than building science?
Yeah, we've done Chris Magwood's. We haven't done the building science one, so that's coming up.
Yeah, all right. So there we go. Big teaser for the building science. And really, think of your house as a system. Think of it as something that's alive, that needs to breathe, in terms of you need fresh air, but you don't want that air to just be going through your walls. And you live inside your house. I recently was at a presentation where the presenter said, "Do you have any breathers in your house?" Basically, like any living human or even a pet could be considered a breather. And those breathers need air. But we don't actually want our walls to breathe air. We only want them to breathe vapor, if that, depending. And this is a system that is not doing either of those things. So then all your air exchange is happening through gaps around openings and at the top of your wall.
Right.
And if those are forced to too much happening through too small an opening, you can get problems. But one of the great things is embedded electricals on the inside of this. You don't get those horrible leaks at outlets.
So one more quick question, and then I'm going to let Sarah jump in. We're going to do a book giveaway, and then I'm going to make sure everybody has the coupon code as well to get your book, and we'll open it up for questions after that. Where do you run the electrical?
Right. So you run the electrical in conduit, basically along the edge of the insulation on the interior withe.
Right.
And you can use, there's some pretty good flexible conduits out there right now, which make the builders happy, but they don't necessarily make the people fishing the wire through very happy. So in my experience, best practice is a solid conduit, and take the time to do proper sweeps, bend it well, and you'll have a lot better time fishing your wire or your cable through, depending on what you're doing.
Cool. All right, Sarah, I'm gonna let you jump in there, and then we'll give the coupon code away, and then let Tim answer a few questions from the crowd here.
Okay, today's winner is Jake D.
Right.
Awesome, Jake. So I'm going to put my email address up there for you, Jake, and you can send us an email, and then we'll connect you with Sarah. And if you live in North America, you can they'll send you a physical copy. If you're outside of North America, then you can get the e-copy, but all the details will be given to you by Sarah once we connect you. So if you guys found this useful and you're thinking about building with rammed earth, I highly recommend this book. Like I said, everything in this Essential Sustainable Building series basically gets you straight to the signal. It avoids the noise. It gets you right to what you need to know. And that's why we're really taking some time to interview all the authors. There's incredible information in here. And I mean, I wrote one of these books, and trying to capture all of the nuance in all of these different books in 50,000 words is a really difficult thing to do. And I'm sure Tim can attest to that. So these authors have really had to make sure that they're giving you the absolute essentials, which is why it's called the Essential Series. So for 48 hours, you guys can get access to the book at a 25% discount. And I'm just going to put a link to the New Society website there, which will take you to Tim's book. You can also just search Tim's book, Rammed Earth Construction, New Society Publishers. And so that coupon code works on their website. Again, you have 48 hours to do that. So now we're going to open it up to Q&A. And just quickly before we do that, if you guys are not on our newsletter, we send out a newsletter twice a month informing people about the talk for that particular week. We also give you guys the coupon code on that email, so it's just a little bit of a reminder. And so you can head over to the Verge Permaculture site and sign up for our newsletter, and then you'll be informed twice a month with regards to what's coming up on the YouTube channel and who we're going to be interviewing. So I'm going to just head back up here. First question actually I have for you, Tim, is from Greg Wade. What about absorption of odors?
Well, we don't have a lot of problem with that with a stabilized rammed earth. We're putting, there is a permeability reduction compound that we put in there. It's a silicate, so it's an emulsion of ground fine silica with a bit of a surfactant, and we put that right into our mix. And that is really, mostly we're doing that to reduce efflorescence, but it also prevents liquid water from penetrating the wall. That gives us great assistance with freeze thaw cycles. But we can still get vapor and going in. So I would imagine that you could have some issues. Often when we have clients who use rammed earth in a backsplash in a kitchen, they will put an external sealer on that in order to make that a really cleanable surface. If you got a really porous surface and you got like tomato spattering and stuff, that might be forever. So a lot of people will put a sealer there. The rest of the house, I don't know of anybody complaining of that, but it's an interesting point because smells are very small, and there are pores in the outer inch and a half, 2 inches of that wall that are exchanging.
Probably just put some Arm & Hammer in that wall. It'll probably take care of all those problems.
I would imagine you could put baking soda in your wall. Yeah.
Beckins asks, is there any way to fix the mixture if you've got too much water in the slurry there, or the fill?
Well, there's a little bit of forgiveness in terms of time, especially if I didn't really get into the binder mixes too much in this talk, but if you read the book, you'll see that we do try to promote lime type binders, which have a longer set time. And so then you can just add more of the dry. But it's always better to approach from too dry and get to ideal than to go from too wet and come back to ideal. There's a bunch of geotech in there too, if you talk about wetting and drying curves. But yes, the short answer is yeah, you could add a bunch of dry and get there. It won't be exactly the same as if you come to it the other direction though.
Okay. Jake asks, how much of the form is reusable?
That depends on your appetite for seeing nicks and bumps and stuff. So the forms can be reused as many times as you like, but every time you reuse them, the chances are that you will have left some evidence of having used them and or cut them or something like that. And we start to see that example I showed you where you could start to see the lines between plywood not lining up. But yeah, there's no, if you're careful, you just clean, you don't use a foam release agent, you just clean them with water. You can reuse them as many times as you like. But again, it depends on your appetite for crisp lines.
Okay. Mark Berg asks, is Alumiform the brand name of the forming system?
I believe that was the brand name of the one that I showed initially. There are a number of them out there. If you talk to any large construction rental firm, United, Hertz, any of those guys, they'll have some version, and they might have steel ones. Steel gets pretty heavy, and we don't need. While we do have quite a bit of lateral pressure. The lateral pressure is essentially resolved at every lift, compared to if you're casting wet concrete, you've got a huge hydrostatic pressure that just keeps building all the way to the bottom of the wall. We don't have that here, so we can use lighter Whalers and Strongbacks. Hopefully that helps. Sorry, cool. I'm not really good with proprietary stuff. Usually just what it is.
Yeah, fair enough. Okay, last question. Hi, here in Ireland, what about an Atlantic coastal site? Is there a need for substantial rain screen?
Again, if you're going to do a raw rammed earth mix, yeah. Or you can do a sacrificial layer. You could look at the work of Martin Rauch. He's an Austrian builder, designer, architect, and he builds raw rammed earth, exposed raw rammed earth, but he builds it with an extra 2-3 inches on the outside that's just going to erode and come off, which is also a different aesthetic. Yeah, gladly, or I would tell you to look at his stuff. Incredible stuff, really. But if you want to do stabilized rammed earth and incorporate some of these permeability reducers, no, you'd be fine. So it depends on your appetite for using cementitious or lime binders, and then attention to detail.
Awesome. Well, Tim, I really can't thank you enough for coming on the show. If you are seeking new clients, do you want to give out your website? And in spite of the fact that your contact form is broken, how do people hire you?
Right. People generally hire me by talking to a builder or a designer that I've already worked with. So one way to reach me would be through New Society. I've had conversations with clients through New Society. The Endeavor Center, which is the educational body that is also, they are the editors of the Sustainable Building Essentials series, and they're invaluable source of information about all kinds of sustainable construction. So reaching out to them will get you, that's just one step away from me. I do a lot of engineering for them. And that would be helpful to me because it would filter, if you will, the questions. They may be able to stick handle around a question for me, leaving my, I don't know, I don't want to sound arrogant, but my valuable time.
There's a lot of, we'll just leave it at that. So I put the Endeavor Center up there. I put your website up as well, but you can't contact him through that. So you got to become friends with Chris Magwood or New Society.
Right.
And if you want to have your own physical coach, I highly recommend getting this book right here. All the details are going to be in the show notes, and I put the links into the chat window as well. So again, thank you so much, Tim. Sarah, did you have any closing thoughts?
No, just thanks very much again. I'm learning a lot in all these conversations. I will be a builder yet, I'm sure of it. Or an advocate, anyway.
Yeah, you're already an advocate.
I'm an advocate.
Okay, folks. Well, thanks so much for signing in. If you found this useful, please give us a like. If you're not subscribed, make sure you do that, and you'll be notified when we go live in the future, especially if you hit the subscribe button twice. And lots of great content coming up on our YouTube channel coming up soon. And we will see you guys in the next video. So thanks again.